Welcome, everyone. Thank you so much for coming. My name is Shalaya Marsh. I'm coordinating the Fab Lab this year, and I have the pleasure of introducing Bri Murphy. Bri Murphy and I have known each other for several years. We met when she was the gallery director at the Lux Center for the Arts in Lincoln, Nebraska. She attended SUNY New Paltz for her undergraduate degree and is currently a second-year graduate student at Ohio University. I did that right? Yeah. Okay, good. I always get the Ohio's confused. Bri's work deals with digital technology and the way it incorporates contemporary culture, or contemporary culture incorporates into digital technology. And I'm very much looking forward to her presentation today. I hope that you all are as well. If those of you who have seats next to you could move in, we're getting a little bit full in the back, and I would like to request that the people standing in the back actually come in and sit down. We need to keep the aisles clear. Thanks so much. And Bri Murphy, everyone.
All right, awesome. Thank you so much, Shalai. And I just, this is just so exciting for me to be here. I mean, I'm really grateful to Shalai for the opportunity, and Shoji over at West Virginia. Y'all have been really wonderful. So let's dig in, shall we? Okay, so here's the very official outline. The big buzzword for me, the thing that sort of tethers this all together, is access. So I have a particular focus on open sourcing, and then the democratization of these technologies. And it's so funny. So when I was looking at the theme this year, the Claytopia, right? It just brought up this. Whenever there's a new technology, people have like either the utopic or dystopic response, right? It's either gonna like change the world for the better, it's gonna be like the demise of civilization. And like, obviously 3D printing has yet to deliver on that, you know, like what it's gonna do. But I wanted to share that with you because that got me tickled, so. So a little background, Shalaya kind of gave you the nuts and bolts, but yeah, I did my undergrad work at New Paltz, and of course Brian Sebez is out there, and he's been one of the pioneers in this whole game. But I do want to say my one grievance, Brian, wherever you are, is that I missed that by a year. So I graduated and then he started doing that. So I had to do some Instagram stalking, and then of course part of this whole like democratic nature of 3D printing and sharing on the internet is that open source. Like Brian posted his designs on Thingiverse, and so I downloaded them, and then I just like Insta stalked him and then figured out how to put it together because there's no manual. But yeah, so it's out there though, and that's the really exciting thing. So that access again, right? So it's there, and if you can piece it together, you can make it happen. And I'll kind of talk about my work sort of like sprinkled throughout this, but the main focus is comparative methodologies, the different things that are out there, the way that digital printing is being incorporated into ceramics, and then sort of the pros and cons of all of those. And then also too, let's like touch on some of the like underlying discourse with all this too. I think that's really important. Like why is it important? And it is. I'm gonna convince you. Okay, so there's gonna be a mixture of the sort of basics and then maybe some more jargony things. So if you want to throw out words like Cartesian, feel free. If you need me to clarify anything, just like interrupt me, and that's totally fine. I should have been prepared. No, so it's right. So Cartesian is like it's box shaped. So it has like an X and a Y axis, almost like just a desktop printer, but then it just adds the Z, as opposed to a Delta printer, which is that one with the 3 arms that comes in, the triangular one. And they have pros and cons. I'm not gonna get too much into that, but if you wanna ask me in the questions portion, see you then. Okay. Okay, so 3D printing is not exactly new anymore. This is our fourth NCECA Fab Lab, so we have a pedigree. But 3D printing allows for a physical translation of digital space. So it's a way of materializing data into tangible objects. So we're going to focus on 3 methods for this: extrusion, which is the most common, powder-based, and resin-based technology. So extrusion first. This is the most common and accessible. And it involves pushing some sort of material, whether it's soft clay or molten plastic, through a nozzle, and then that's typically uses compressed air or a mechanized plunger or a little gear that pushes that plastic through the nozzle there. So a layer is laid onto the build plate. That's that bottom, and then the nozzle lifts on the x-axis and continues as it goes. So resource number 1 is the free beginner's guide to 3D printing, and that's on 3dprintingindustry.com, and they're cool with me using their images, so I asked. But this is really great. So you see you have the, can I use my mouse? No, I cannot. You see there's that filament, which is just plastic material being fed down into that. Essentially what it is a glorified hot glue gun. And then it's creating the Yoda, which is a really good model. But, and then, here's some popular consumer level printers. They come from a range, if you want to spend just a couple $100s to build one yourself. That takes a little bit of electronic know-how, but there are so many forums out there that you can sort of piece it together yourself. So I built one for $250, or you can spend a couple $1,000s for a MakerBot that comes just ready to use out of the box. So there's a wide range of options out there. There's a little action shot. This is the Maker Gear, which I really loved using, and the first time I tried this out was with Shalai over at West Virginia. They have an awesome space, and I have a couple images in there. Some name drop in. Okay, so those are the sort of desktop mainstreaming 3D printers, and then of course we have the adapted versions, and there's the Delta, and here's some gratuitous Insta porn for you. I know. Yeah. Oh, there it goes. So this is Brian Seabez's design. Then you have the Jonathan Keep lineage. You can find all that online. So there we go. There we go. So Tom Bartel is, like Shalaya said, I'm a grad student over at OU, and Tom Bartel's on my committee. And his 4-year-old daughter saw my work and was like, "Daddy, noodle doodles." And I think that's just so perfect. So noodle doodles. So there you go. There's a jargon word for you. So the really great thing about the extrusion method is that you can adapt pretty much any clay body. So if you have whatever you like to use in your studio, this can be a complement to that. So you can take any clay body and adapt it for this. And then you have the same sort of factors that will affect your work the way anything else will, like which clay body you use, the consistency, how soft it is, if it's so kind of runny that it just tends to slump, or if it's kind of stiff, maybe you get that sort of like shortness, that cracking, or the plasticity, the humidity, anything can affect this thing, right? And then also you have other factors that are this process specific, the speed of the printer, the pressure, how much airflow you're giving it, if it's really just like squirting out a ton of clay. Somebody bumps the table because they're like, whoa, 3D printing. I mean, like anything can influence this. So like it's very environment sensitive. And that's what got me really excited kind of in the first place, was that sort of the inherent properties of both the material and the process. They produce a set of parameters, right? So we think about the possibilities and the limitations, and it's the pros and cons are the same. And it's just about if you want to work in that space or not. So I really love these sort of crappy, low resolution versions of Lady Liberty because of that like visual language that is produced by the printer. So this idea of taking a perfect digital model and then filtering it through the printer, and the printer acts as this sort of mediator between the digital and the physical space, and then this is what you get. And it kind of did the work for me, right? Like the poetics of the situation, I guess. And then we have a complete collapse. I love this piece. I could never make this in a million years, but you know, I left and came back, and this is what had happened.
Have you named any pieces new given?
Not on paper, just fondly, you know. And you're all part of the joke now, so that's pretty great. So I love this sort of like material versus machine thing that happens. But anyways, so here's like a little insider thing. So like Kilns, printers all need names. It's really important. They're squirrely anyway, so you need to just do it. Save yourself that headache, anyways. So on the left there's K-State's Thixotropics. I think Amy Santaferraro was there. Yeah, there's Brian. And then that's my printer on the right. That's Link. Any Zelda fans out there? No, the green fixtures. Also, I built him in Lincoln, Nebraska, so we got like a little double thing, a little pun going there. And then, okay, so with Link, all right, back. With Thixotropics, you see that, just that plastic canister that holds about 300 ml of clay. And then I have the Wasp set up. So Wasp is the World Advanced Savings Project. And they're one of those guys, they're based out of Italy, and they're one of those guys that are doing those like really huge concrete 3D printing things that you see. But they have this clay kit. I mean, you can purchase one of their printers outright, or they have on the right image there, the kit that you can buy for 650 euro, if anyone wants to translate that for me. But there are open sourced versions of this sort of print head. So it combines the air pressure with a mechanical auger system. So because it can go forward and backward, there's a screw in there, you get a start-stop. Whereas with the other one, you just have straight airflow. So in that case, you'll get that sort of like bridging between two separate sections. And in this one, you know, you can do those more complicated bits freestanding without that sort of bowing bridge in between. So great tool, kind of expensive. Actually, that cost about twice as much as the rest of my printer. And I would have loved to try to piece that together, but I got a grant, so I didn't have to. So yeah, I got a grant through Ohio University last year, which has allowed me to do things such as go to Tethon 3D in Omaha. And they're doing both powder and resin printing. So perfect segue, Bri, good job. So powder printing. So there's dry ceramic material, which is hardened with a liquid resin or binder, and then that sort of glues it into place. And here we go, 3D industry schematic for you. So the infrastructure is a little more complicated and more expensive, so accessibility not as much. The printers themselves are reused Z Corp printers. They're a few thousand if you can get a good deal, maybe around 10,000. And then the material itself is proprietary, so you can't just throw a dried out version of your clay body in there. You got to order it through Tethon. But they're really nice, they're great. So basically what you have are those two chambers, the powder supply, and then you have a little roller or a squeegee, and that will bring over a layer of powder. And then the inkjet print head is literally just an inkjet, like black ink that you purge, and then you funnel in some, the binder through like a little side little portion there. Let me just show you a video, that's a lot easier. Okay. So literal print head, right? There it goes. So one super thin layer on the print bed.
This is powder right now?
Yes, and then it just dragged over a layer of powder. Do we want to see that again? Yes, so it's a like a thin layer of powder. Is that going again? And then the inkjet printer, just like a desktop printer, is is printing that liquid binder, and that's solidifying the powder. And then there's a little squeegee / roller, pulls over a new layer, and the build plate drops down just a little bit. We got it? Cool. It's cool, right? So here's just the straightforward 3D model of the Liberty base. And then here you go, your comparative methodology, your side by side. So on the left is the extruded, and on the right is the powder print. So the powder resolution, much higher. It is as fine as the particles are, and the unfinished clay has this like really nice sandy surface as a result. Neither is inherently better than the other, they're just different. And one is more expensive. So this is, these images are from my time over at T-Thon this past summer. And I have a bunch of these little snapshots here of the interior structures that support the build. So this is the base again for the Lady Liberty piece. And you need to have support structures or infill if you're like plastic printer savvy, the infill that supports the outer shell. Because especially when you start printing larger, you have, I mean, it's clay, right? And it's uncompressed clay particles. So they're gonna have a propensity for warping or slumping. So you build up some sort of lattice on the inside, and then that helps to support the outer shell. But because of this lattice structure, you have these sort of really beautiful patterns in the cross section that probably are better than the actual piece. But here's another little video for you. So we've got a couple of Lady Liberty bases being printed now. You just watch it all day, right? And the really great thing about the powder as well is that it's literally building a cube of powder. And so all of that exterior powder is just a support in and of itself. So you don't need any exterior supports because that powder is just there. It's holding it up. With this process, there's quite a bit of post-processing. So after the print, you have to excavate those models. Super like gratifying, very, yeah. Wear your mask though. And then so you get the bulk of it off, and so the thing about this stage is that it's extremely fragile. So you can see Max there from T-Thon holding that build plate, and there's quite a bit of powder still on there. So what do? You just pop it in the old oven, let it bake for a couple hours or 8 hours. Let some of that moisture kind of come out, and like I said, really, really fragile. But after it's printed, it has some really, really nice properties. That porosity makes it really, really resilient to thermal shock. Like you could hold a torch to this thing and it wouldn't crack. You know? Like 200 degrees, you know. You're just baking it to get the excess moisture, and then you fire it in a kiln. So you bisque to cone 6, right? And then you can downfire with the glazes if you'd like. But then there's that nice lattice work on the inside. So all those beautiful patterns from before. And so with this too, there's also, when you're modeling, you have to keep in mind that there needs to be an escape route for that extra powder. So there has to be some sort of opening to dump it out. Otherwise, you're gonna have a solid clay object in the kiln, and you know what happens then. And just to show you some, so that interior lattice work in a digital way, this was generated in Mesh Mixer. And I'll show you that kind of in the software portion of the day. And and then I just sliced it in half for you so you could see what that inside looks like. So just sort of a network, spiderwebby thing to hold it all together. Another real benefit of this, this particular method is because it's so precise, then you can make these interlocking parts, and they fit together really nicely. Con, they're still kind of fragile, especially those little parts. What a headache. But again, I was talking about that porosity that's really wonderful, and it's amenable to bisque fix. It's Amico bisque fix. You just put a little bit on each side and smush them together and fire it again and stick together, good as new. It's pretty nifty. Okay, so here's another piece that was in process. We maxed out the build volume, which is only 8 by 10 by 8 inches. So there's another limitation. Of course, the workaround is because they can interlock, or you can attach them even with the BizFix. You can build larger. It's just in modular sections. But then there's the finished, well, fired, the bisque, and then there's just a white clay slip on there. 3 of those arms broke off, reattached with the bisque fix, and then this is just, I think that this kind of, this work sort of ticks the box of why digital, you know, like there's that question of why. And I don't know about you guys, maybe some of you guys could do this, but I couldn't build this by hand, you know, and using the algorithms within the software program, I can say like, take the model, step it over 1 inch, turn it 30 degrees, and just do that, you know. And so then I finish this off, and I call this one about face. And then as far as the surface goes, I was thinking about a gold toilet. This is political, so if you want to leave right now, no, I'm just kidding. Don't go, there's still a lot of good stuff. Okay, so moving right along, now we have the resin. So resin is a liquid print material, so this is a combination, once again, proprietary. You can get it through Tethon, and then there are some other companies like Formlabs that are starting to make some products as well. So it's a mixture of UV curable resin and clay. They will not tell you how much clay to resin, so don't ask. And so the liquid state allows for a much finer resolution, and sometimes like you can barely even tell where the layers are, especially after firing. So here we go again, and so you have that sort of vat of liquid there, and basically there's a little laser beam, and anything the laser touches hardens. That easy. And then here's another process that's very similar. It just uses a different laser versus concentrated light. The 3D Systems Fab Pro 1000, that's one of the printers that Tethon is using. And that will run you around $5,000 for the printer. So again, access, like not quite as easy to get a hold of, at least on a personal level. I have to write a few more grants. But this configuration is probably what we're used to seeing. Like we got a form over here. It's that upside down build plate. It'll go down. And then if you watch kind of right at the base there, I don't know, the orange, I get it because like they don't want your retinas to burn, but like it's really hard to get good videos. But if you watch just kind of like right at the base, you'll see that little light kind of like flashing around. See that, right? So it dips in. Come on. There we go. And then it squeegees across and lets a new layer of that gooey material kind of settle. And so it'll build upside down. The Form 2 will run you around $3,400. And they also have a new product, their ceramic resin. TBD, I think, on the Yelp reviews. It has the pro of being a little cheaper than the Tethon version, but the Tethon material has around 14% shrinkage in every direction, and the Formlabs version is about the same, except the Z axis, which shrinks about 30%. So their slicing program actually skews it so that it, I don't know about all this. If somebody's messing with this and wants to let me know, I'm really interested. But this is not something that I have in my studio, so maybe Shalaya, you can update me at some point, because they have one over at West Virginia. So, but back to the Tethon business. So their porcelain, pretty great. It has that even shrinkage. There we go again with the upside down build plate, and the precision is just unbelievable. I have a couple of examples over there if you get a chance. But so I printed my standard, my Lady Liberty over there on the right, and it was just too good. At that point, why bother? It's an expensive material. I mean, I could just go and buy a little tchotchke on Amazon, right? So it's where's the content? So I couldn't really rely on the process anymore. So those two on the right, I had to then kind of go back and think about, okay, so if the process isn't gonna prop up the work as much, then I have to think about another way to generate content. So editing the model, creating this sort of lattice, transitioning, is it building, is it disintegrating, and I call those a crumbling infrastructure. I know. Hey, only I can be political. Okay, so like any of these processes, you have to consider the modeling. There's some holes there so that we can drain that excess fluid out. Also considering, there's a little slice and dice for you. Also considering, time and process, or the time and the cost of the material. So if we can print it nice and thin, we'll save on time, we'll save on material. There is also post-processing that goes on with the resin. It has to sit in an isopropyl alcohol bath for a while, agitate it. It smells, and not great for the skin either, hence the gloves. And then all those little support points have to be either snipped or filed down, or you have to decide to live with them. So again, all things to consider. If you hate it, don't do it. And then, the thing about 3D printing is you get a lot of failures. You fail all the time, and that's okay, because it's really common. You're not the only one. And I think, especially as artists, we're always trying to push the boundaries of things. I get there and they're like, okay, what do you want to start out with? And I'm like, Lady Liberty, and she's kind of collapsing, and they're like, whoa. I'm like, no, we're doing it. So about half of them failed, of course, which, and in this case, that upside down print technology, I think there's oftentimes a lot of suction that can pull those off. So again, it's just about finessing the material. It's like a kiln in the sense that each printer is a little different. You figure out the quirks. But then some of the results can be pretty beautiful. And then it's just about knowing what's possible and choosing the right strategy for what you want to do. But there it is again, the scale. And I call this one, you're a little two-faced. I know, I'm full of them. All right, so let's talk a little about software. Again, my focus is on open source, what's accessible. So everything before we print has to start as a digital model. And I like to talk about the speed of the digital. So again, why digital? It gives the ability to iterate much more quickly. So you can rapidly generate and evolve your ideas without the sort of limitations of time and materials. So you can work through processes more quickly, or concepts. So I always start folks with Tinkercad. It's from the Autodesk suite. They're really great. They actually offer educational licenses for some of their not free software. So, I mean, you can get some of this like cutting edge technology for free. You just fill out the educational little thing. I think it's like 3-year license at a time. It's wild. And then Tinkercad is just very intuitive, basic shapes, addition, subtraction, and it's browser based, and there's a lot of great tutorials. So that's a good starting point. Mesh mixers in the same family. It's a maybe like medium level of difficulty. And this is just another one of those why digital questions. Like, just like slip casting might offer the opportunity to alter multiple versions of the same form, the on-screen modeling can further expedite that iterative process. And the digital object can be copied and saved, and if you hate what you did, you just go back to an earlier version. So there's like that. There's no hesitation anymore. You can be completely free to experiment. Maya, super difficult. It's not terribly intuitive, but this one has a particularly steep learning curve, but then it has some really great and powerful functions. This is one of those that's paid, but again, the educational license. Sculptress, I have almost nothing to say about. I hear that clay people really like it. Maybe I've just never been as much of a modeling kind of person, like the physical. But it literally starts you with a ball of material, and then you can like pinch and pull and and sculpt. So that's one to try out. All right, moving right along. So slicing, once your model's ready, you use a slicer program to literally slice that into steps. And then once you have that, you can start fiddling with those settings to get some variation as well. My recommendations. A lot of, like Wasp, for example, has pre-settings for both Cura and Slicer, so you can just put those directly into the program, then you're good to go. You don't have to just start from scratch. There are fancier versions, but I don't think you need them. A couple little screenshots here, and then you see that sidebar. You can there's like 100 different options. You can change like the level, how much it steps up. You can change how much infill you want for support. There's a lot of different possibilities there. And then there's the Repetier host with Slicer. And then at the end of all this, at the end of the print, no matter what your process, you have a ceramic object that in some cases you can work directly with thrown or print or thrown or hand-built clay, or it might have slightly different properties, but glaze, luster, anything you want to do, it's the same, it's the same set of possibilities. Okay, so Bri, why are you so crazy about open sourcing? Like I said, it's about the democratization of information and technology, and that's made possible by the pervasiveness of the internet and then American freedom of speech and freedom of information. And that like gets me going about the utopic dystopic thing again, like 3D printing, and then the 3D printed gun in 2013, and then there was 100,000 downloads of that thing in 24 hours. You think about that, and then you think about like people going on missions to underdeveloped countries and bringing a 3D printer and printing prosthetics. So there it is. Like there's the dichotomy. So online repositories are this sort of like collapsing of space in the sense that, I guess literally with NASA. Oh God, that was supposed to be a pause for laughter. Collapsing of space? Come on. Okay. So these are like Google type search engines, they're both like crowdsourced and institution sourced. So NASA, the Smithsonian, we're seeing an increased amount of institutions that are digitizing their archives, because in theory, the internet is forever, but material might not be. So keeping those artifacts in a different way, a different kind of archive. Scan the World is wonderful. They have 14,530 printable sculptures and counting. It's this sort of online museum, and there's sculptures and artifacts from around the world that you can access. And so again, that collapsing of space, like access. Like if you don't have the privilege of being able to go to Florence to see, I mean, you can, you're like, it's gonna be like a little like baby version. Okay, I get it, but it's something, right? And it's that sort of like hands-on experience that we think about giving people that can have some really profound impacts on methods of learning. And just the ability to sort of like collaborate in a way, like you get to collaborate with these like other makers or these historical objects. That's kind of beautiful. And then sometimes sourcing just means getting really creative. So I wanted a bust of Thomas Jefferson. But there's a Franklin one that was scanned. There's a Washington, but there's no Jefferson. So I ordered like $100 replica from Monticello, and then, oops, back up. Then there's this kind of old tabletop scanner at OU that I used. I might have returned it after. I don't know. And just like, how do you get your hands on things, on a budget? That wasn't part of my grant. And then you can also pay for models. And I mean, I had a really, that goes against everything I've said so far. But there are people that do this for a living. And I decided that I really wanted this architectural element to put my bust on. And I didn't want like part of my 10,000 hours to be learning how to do this, which would have taken me forever. So I just paid $15 for it. I mean, not a bad investment. Definitely not a bad investment. And we tried to print that on the powder printer, and I accidentally didn't, I forgot to hollow it, so it's solid. So this didn't work. Like I said, sometimes it's user error, but you have a lot of failures, but that's okay. But there's the sort of first version of this. And so I ended up using just a 3D printed plastic for the base, and then I gold leafed it. I like gold, obviously. I'm just making the connections. You know when you look like through your portfolio and you're like, oh my God, it's all the same. So this really nice like structural juxtaposition of the looseness of those noodles, and then that sort of like tightness of the corbel, which is the technical term for that little pedestal. So I guess getting back to that excavating, that idea of digital archaeology is something that's really exciting. Mining the internet for information. This is a right center stage there. There's a mastodon molar scan that VCU has a really great, very robust program with a lot of great like scanning technology, and this was in a New York museum. And anyway, he scanned like a couple hundred artifacts, and so we printed this at West Virginia, and it was just so satisfying for the 4-year-old version of me that used to bury sticks in my backyard so I could excavate them, So this is like fulfilling that, I suppose. And I was really kind of stoked with that. And then I have to put a plug in for a Wiki Factory. If y'all are familiar with Google+, the build your own ceramic printer page, Google+ is going out, and so it's been migrated over to Wiki Factory. You can just join this, and it's like the site for if you want to build a ceramic printer. It's a site for sharing, and it just encapsulates kind of what I've been talking about of that sharing of information, and the folks there are super generous and knowledgeable. Okay, so let's round this conversation out with some pedagogy. And again, for me, it really comes down to access. And then the caveat, of course, is that accessibility is more to economic and educational privilege. So even though great strides have been made to place digital tools in diverse spaces, a lot can and needs to be done to really democratize this kind of technology. A few $100s towards a DIY printer kit is a marginal investment on an institutional level that can yield a great bounty for students who otherwise wouldn't have access to these kinds of things. And it's a growing trend in schools, libraries, nonprofit, and then of course the huge network of makerspaces that are popping up everywhere. West Virginia, once again, you guys are great. And not just like digital technology logically fits into academic settings, right? Like for a number of reasons. Students who grow up with computer proficiency can navigate the language of modeling software pretty easily. And then they also benefit a lot from the translation of like the familiar digital landscape to analogous tactile experience. So a real argument can be made for the folks who maybe spend too much time on digital devices. Like this could function as a bridge to bring the digital into the physical space. Tomorrow there's a panel in here building a digital toolbox for the classroom, and that seems like a good place to collect some more information about how to do that. And I would advocate for both students and educators to go to that too, because oftentimes it's the students that drive what the program turns into. Like if you vocalize this is what you want, then sometimes you can make those things happen. Yeah.
So you could watch it on the site.
This?
Then tomorrow.
Oh, yeah.
You also have to go home.
Oh, shoot. Yeah, no, all of these are being recorded and will be online eventually. Yeah. So it seems to me, here's my conclusion, you ready? So it seems to me that the spirit of 3D printed ceramics, or any other digitally infused ceramic method, is the energetic response of those working with traditional materials who want to engage in a conversation with the changing world around them. So I argue that at the heart of both maker and ceramic culture, there lies an intrinsic desire for community that is altogether altruistic. While a capitalist market certainly factors into the ways information and products are dispensed and consumed in the United States in particular, the nature of digital open source phenomenon mimics the way that artists and educators have shared knowledge throughout generations. And finally, to recenter on one of the most basic questions when it comes to digital tools and ceramics, do they belong together? I think that the potential is not in their simple coexistence, but rather in the opportunities to collaborate in meaningful and profound ways that span history and connect like-minded makers around the world. So, do we have any questions? That's it. Sharon.
Surprise.
Yes.
Question.
Great.
Okay, so I'm very, very set in my ways as an older woman who's been teaching throwing and sculpture and
Sure.
started age 3.
Mm-hmm.
And I don't know anything about programming or anything. The library has a 3D printer.
Great.
How do I transition my students in a way that I can be comfortable with as someone who's not, like, I still have trouble sometimes using Google Drive.
Sure. Can your students use Google Drive?
Yes. Oh, of course they can.
I mean,
Do things with my phone that I can't believe.
yeah. Well, you know, I think a big part of it is working with them, you know, like working collaboratively, because especially if they're engaged and they're really interested, like they can drive that, you know, and I think that can be, like you can support them in doing that, you know.
If there's a, so there's
Right. So is there a way to bring things from your printer to the library to print them from your computer? Absolutely. So Brian Seabez has all the things that you would need to build one of these printers on his Thingiverse page, and he has even an entire list of materials that you need. And all you do is take those files, you put them on the computer, you get them ready, slice them, and then you bring it to the library and you plug it in. There's an SD slot on most 3D printers, and you just pop it in.
I know what that meant.
SD card, there we go. Yeah, so it's pretty straightforward, but yeah,
Oh, cool.
absolutely.
Oh my goodness.
Easy.
It's doable.
It sure is, yeah. And if you're really confused, you can bring me in and I'll help you.
Connecticut, honey.
Connecticut? I'm from Vermont, New England.
Oh, you're from Vermont?
Yeah, well, I'm in Ohio right now, but, you know.
I'll wait till you get home.
Okay, sounds good. Other questions? Yeah. Yeah, so the question is there an advantage to doing DIY versus out-of-the-box 3D printers? I say yes, because of the failure thing. Like a lot of things can go awry with the prints, and it's really useful to be able to troubleshoot yourself. Of course, if you buy out of the box, a lot of those companies have support. So I guess it really depends on how much of an investment you want to make in learning about the printers or being able to troubleshoot yourself. If you're kind of a fixie sort of person, then there's a real benefit to building from scratch. Otherwise, you know, if it's a means to an end, like I just want to make this, then yeah, buy out of the box. Does that work? Yes. Right, so the question was, in the resin printers, can you reuse that material? Because it is very expensive, you're right. And then I think you said the recommendation is like 50% virgin material, right? Like that. Right. Yes, you can just reuse it. So I think sometimes we might have sieved it back in. And then also sometimes the ceramic can tend to settle a little bit, so maybe you pour it out, give a good shake, and dump it back in. But yeah, you don't need to add additional material unless you're running low. Yeah. So that'll save you a couple pennies. Yeah. Yes. Yeah, so the question is, do you worry, especially with the extruded process, do you worry about the strength of the objects? Yeah, I mean, but there's like really fragile stuff everywhere, you know. But yeah, I think that comes down to consistency too. If you're using soft enough clay, you don't need to worry about like the scoring and slipping and all that. Like it will just sort of, the weight of itself will kind of squish it together enough that it's not really an issue. And then as far as like the fragility of the piece all around, you just get really good at packing. You know, I can show you some of my packing materials. So question, do you worry about air bubbles? No, because I embrace whatever happens. So like I'm very okay with the air bubbles. But it is an issue, you know, especially with like the cartridge, loading the clay straight in yourself and having the continuous feed, you can get air bubbles, so you have to go through a process. Jonathan Keep has a video on his website on how to prepare clay for extrusion. But the newer sort of auger-based methods, those print heads can help de-air as it goes through, so it's less of a concern. And then that external feed tank is like pressurized, so that can compress the clay as well. Does that answer your question? Question was, there's a battle between Wasp and its like slightly more liquid clay, and then Potterbot with its more firm clay. Is there an advantage? I think it depends on what you want to do, because a lot of the Potterbot, as far as I've seen, the drier material kind of necessitates a larger nozzle to push that material out. So what's that? Because of the stiffness, yeah. So you can build more quickly because those coils tend to be bigger, and it's going to be probably stronger unless with the Wasp you're adding in a bit of like infill. But I think you can get much more precision with the Wasp because it's softer. So you just think about resolution, you know, that smaller nozzle. The Wasp comes with a 1 millimeter nozzle, so it is pretty tight. It all just depends. It does? Okay, so apparently the Potterbox does come with a smaller nozzle. Okay. That one isn't, yeah. I haven't messed with the Potterbutt much, but yeah. Yeah. So the question was if somebody wants to take something they've made out of clay, digitize it, right, and then re-export it. Yeah. Does it take any fancy equipment? You can, it does, but there are other options too. I'm not super familiar with those though. There's like, do you got something? Yeah, photogrammetry, for anyone that didn't hear that, is a way of like splicing photos together to give you a digital model. So yeah, that's sort of on the long queue of things for me to experiment with. So yeah, thanks for your help on that one. The printers themselves are compatible with both programs, both platforms typically, but a lot of modeling, especially the more fancy modeling programs, are PC. Yeah, yeah. Darn you, PC people. Yeah. So the question was, do you have a list or like a resource for the list of parts? I would just go back to the Wikifactory page. That's gonna, it might take a little sifting on your end, but people are sharing on that all the time. And the other thing is there's a lot of DIY builds of different printers online that are not necessarily ceramic, but it wouldn't be too difficult to adapt those, you know, using just some basic alterations with a couple of parts. But the Thingiverse page that I was talking about, the CBES has a whole bill of materials. It's CZIBESZ. Yeah. What? Okay, his Thingiverse username is Zibes, ZIBES. Yeah. Absolutely, yeah. So additionally, Jonathan Keep on his website has a similar build even, yeah. So between those two, like I said, Insta-stocking, really, it goes a long way, you know. And then if you ever have like a chance to look at somebody else's printer that's work, make sure it works. And then like just like have a look at that ramps board and be like, okay, and just like write down, you know. Yeah. Yes. Yeah. So the question was, what kind of firmware are you using? And then are you using an open source board, ramps board? Yeah, it is a RepRap. Yes.
Are you using like Marlin on it?
Oh, yeah, it is Marlin. Yes. Sorry. Two-parter. Right, so in browsing options for open source software, Blender is an option too. The thing is that Blender's fine, let me tell you. It is great. Like, they're all different. They're all so different that you just kind of have to pick your avenue and kind of run with it. Unless you can migrate over from different platforms, like all of the control keys are all different, so get like scrambled brains trying to do it. But yeah, Blender's perfectly fine. Yeah, right. Any of the ones that I talked about, like Tinkercad, Mesh Mixer, you know, and then the slicing programs, Cura Slicer, all of this, including my presentation, should be online soon. And then also I'll host this on my website too, and I can, you know, make sure that that's available as well. Yeah. Also, you can contact me with any questions. I'm very reachable.
I will get your card.
Great. Thank you so much. This was awesome.